Quadratics, we have been solving quadratics. You have been creating parabolas. This looks like we're going, we are done with quadratics. Except Monday, you will begin working with the quadratic formula.
I'm dropping out now.
So, yeah, we've got to figure out what to do up here. So that is what today's lesson is about. Okay? It says simplifying radicals. What do we call that signed thing that's sitting with the 18 underneath it for number one? It's a radical. Who can tell me the purpose of a radical? What does it mean? What are we looking for? It's not division. What? The square root. So if we had a problem that was radical 25, what would the answer be? 5. Not 5 times 5, not 2 5s, but the breakdown of 25 into its square root, 5. And it would be wonderful if every time we had a radical, which is that little symbol, we had a perfect square underneath it. But, then there's the real world where we don't always have a perfect square. So what we're going to do is figure out how to find the perfect squares. So I have also learned with this lesson that you guys do not all know your divisibility rules. So let's say, how can I tell if a number is divisible by 2?
It's an even number.
Even. So that one's an easy one. How do I know if it's divisible by 3?
You add them together.
Add your digits, and if the sum of that number is divisible by 3, 3 goes into it.
Like if it's 8 and 1, you add the 8.
8 and 1, 8 plus 1 is 9.
Gotcha.
What about 4? How do I know if 4 goes into it? There's 2 things about 4.
The first number is divisible by 8, the first 2 numbers.
Last 2.
Last
If the last 2, like the ones and the 10s, not added together, but the last 2 happen to be 28. So it could be like 4,293,028. 4 goes into 28, so it's going to go into that whole big old problem. Also, if it ends in 0, 4 will go into it. What about 5?
It ends in a 5. Or a
Ends in 0 or ends in 5? What about 6?
3.
If 3 and 2 go into it, 6 will also go. So an even number and divisible by 3. What about 8?
The last first 3.
The last 3 digits. You may have a big stream of numbers, a long set of numbers, but if you can divide the last 3, it's kind of the same rule for 4, but the last 3 digits, or if it ends in 0. And then 9. Add
Same thing as 3.
the same as 3, but add them up and it's got to be divisible by 9. All numbers that 9 goes into, 3 will go into, but not the reverse. And then what about 10? 0. The only one we don't really have a look-see for is 7. So sometimes you may just have to work with 7. That's what you're going to be asked for on Monday's quiz. Gabe, I saw your hand first.
You said before that they all end in 0. If they end in 0, they're divisible by 4.
If it ends in 0, it's divisible by 4.
But what about like 50? You
50. Let me go back. I take that back. It's got to be, I think it's 2 zeros. 2 zeros and 2 zeros for 8 and 4. It's 2 zeros. Yes, sir.
What do you mean 28? Like what?
So, well, can you take the number 28 and divide 4 into it? It gives you a whole number of 7. Or if it ends in, say, 36 or 20 or 16, no matter how long the number is, if the last 2 numbers, you can divide 4 into it evenly, then it will go into the whole number.
Like, what if it's not? What's just a 2-digit number?
Well, then you have to know your the factors of 4. All right. So here we go. We're going to look at these numbers that are underneath our divisibility sign. Our radical sign. And we're going to break them down further and further. Girlies, I need the talking to stop. Thank you. Break it down into factors. Now, what we're looking for is perfect square factors so that we can remove parts of them. So sometimes we're going to remove everything and we won't have anything left under the radical. But sometimes we'll remove one number, sometimes two, sometimes three, depending on the number. So while I know there are several factors of 18, and until it comes out, it stays under the radical, what are two factors that you would suggest we use? 9 times 2. Which of those is a perfect square? No, 2 is prime. 9. 9 comes out as what's the square root of 9? 3. And 2 is the left behind. So 3 radical 2 is the simplified version for radical 18. Now, to check yourself, take the number that's outside and square it. What's 3 squared? 9. And then multiply it by what's left underneath. 2, and that gives you radical 18. If you square 3, then it can be back under the radical. You see what I'm saying? To kind of work it backwards to check yourself. So 64.
It's just
8. Abel's?
Oh, so it's 3 and the 2, your final answer?
3 radical 2. Not just 3 2, but there's just a radical sign. 3 radical 2. 2 is not a perfect square, so it has to stay under the radical.
So like whatever is left over?
Stays under the radical. It only can come out if it's a perfect square. All right. What about 27?
9 and 3.
So 27 breaks down into 9 times 3. Either of those perfect? 9 is. So we're left with radical 3 underneath. So 3 radical 3. 8. Boy, it sounds like it should be a perfect square, but it is not. You tell me what the answer would be.
2, 1, and 2.
Nope.
3 and 2.
Wait, what?
3 and 2.
3 doesn't go into 8.
2 radical 2.
2 radical 2. 2 radical 2. Well, if it'll write. So, if we have 8 underneath the radical, that breaks down to 4 times 2. Which one's a perfect square? The 4. The 4 breaks down, though. What is the square root of 4? 2. So the square root comes out from underneath the radical. And it's like when you look at number 3, we had radical 64. It doesn't come out as a 64. It comes out as its square root, which is 8. So the 4 doesn't come out as a 4. It comes out as its square root, which is 2. And then the left behind is the 2. What about 9? We have radical 36. Just plain old 6. Now, if you did not see that, what if you went, 9 times 4? 4 is a perfect square. So is 9. So let's look at that. If you said 36 and you decided 9 times 4, is 9 a perfect square? Yes, it comes out as a 3. And is 4 a perfect square? Comes out as a 2. And what is 3 times 2? 6. So you can go either way with that. All right, 256. Of what? Do what? 16. Now, did everybody know that? So do you want me to, Gabe has enlightened us with that fact, but do you want to break it down to see how it works? Just for exposure to the process. So, divisibility rules. 2 would go into it. Will 3?
No.
Because it's 2 plus 5 is 7. 7 plus 6 is 13. 3 won't go, therefore 6 won't go. Would 4 go into it? 4 will go. 9 won't go. 10 won't go. 5 won't go. Let's try 4. So 256. And we're breaking it down by 4. So how many times will 4 go into 25? 1 more. 6, because 24. And then 25 minus 24 leaves us with 1. And so 4 goes into 16. How many times? 4. Do y'all see what I just did? Y'all good with the division part? All right? Are either of those perfect squares? 4 is, and what does it become? A 2. What about 64? 8. And what is 2 times 8? 16. And that's, and 16 times 16 is 256. All right, nothing left behind. They both break out. All right, 192. 2 goes into it. That's an easy one. What is 1 plus 9 plus 2? 12. So 3 goes into it. 4 goes into it. 6, because 2 and 3 go, 6 goes. So where do y'all want to start? Want to start with 6? 192 divided by 6. All right, we'll write it over here. 6 into 19 is how many? 3. That leaves us with 12. And that gives us what? 32. All right. Good. I want to show you how this, y'all need to see this part. So 6 and 32 are either of those perfect squares? No. 6 breaks down into what? 2 times 3. What about 32? 4 times 8. Anything perfect yet? 4. It comes out as a 2. What I'm doing with that little square every time, it's kind of like my playpen. I throw all the numbers I pull out into that box, and then we'll multiply them to find the outside number. So we have a 2. All right. Sir.
Where did you get the 8 from?
It's supposed to be 30.
Oh my goodness. I went 16. Thank you. Thank you. I was thinking 16. 2 times 3. Glad you caught that. Making sure you were watching. There we go. So, what about 8? It's not a perfect square, but can we break it down further?
Yes.
Into what?
4 and 2.
4 and 2. Hark. Do we have a perfect square?
Yes.
What?
4.
4, and it comes out as a 2. All right, I want anything else. We have a 2 and a 3 and a 2. None of those are perfect squares, but I want to show you this. We have a 2 right here, and if we were to multiply that by that 2 that's still underneath, what would we get? 4. And that would give us a perfect square, which means it breaks out as a 2. All right, and then we're left with what? What's underneath that hadn't been used? The 3. All right, I'm just going to say this. That seeing the 2 2s may have thrown you a little bit. But let's say when we got to that point, you were done. Because a 2 isn't perfect, the 3 is not perfect, and the other 2 is not perfect. What does that give us? 2 times 3 times 2. 12. We would be left with radical 12 underneath. And at this point, we would have just 2 2s. I'm just going to kind of cross that out for right now. But you need to ask yourself every time, are you through? Could you break 12 down any further?
Yes.
And that's where we end up with our 4 times 3. So if you don't see that you have this 2 that can combine with that 2 to make 4 that can come out as a 2, look for your pairs that are left behind. Then when you're through and you make it a 12, you can break the 4 down into that other 2. So where we have left, what's 2 times 2 times 2? 8, radical 3. So 64 times 3 will give us 192. All right, are y'all good with what we just did? I'm looking at Avery, looking at Abel's. Y'all were thinking, Abel's?
What are you supposed to put inside the, like, what are you supposed to put inside the radical?
Whatever you have left behind underneath it, and we had a 3. Right there, we also had it boxed over here.
Well,
And there it
you have
is.
to reduce the 8? Or,
The 8 came out 3 different times. The way the 8 was created to be on the outside was you had a 2 that was removed, another 2, and another 2. But they're outside now. You don't break them down once they leave the radical. They are just combined. You multiply everything that's in the box. 2 times 2 is 4 times 2 is 8. And when it's outside the radical, it is just that pure number. You're not trying to break it down any further.
how do you know if you're going to put something in the radical when you're going to put something in the box?
Well, so let's go back and look at the beginning of 192. We broke it down to 6 and 32. Neither of those are perfect squares. So nothing has left. We broke 32 down into 4 times 8. 4 is a perfect square, right? It breaks down into a square root of 4 is 2. So the 4 comes out and a 2 goes inside the box. The box represents all of the square roots that were created by the perfect squares found inside the radical. And so here is 1, 2 that we found. Here's another 2 that was created, and the other perfect square. And then whether you saw a repeat right here of 2's or this 4, all 3 of those 4 break down into 2 and 2 and 2 as perfect squares.
Do you have like, so if it repeats, like just one of them happens? Or
Well, like, what's the square root of 4? Is it 2, 2, or is it 2?
2? Like if it's, like, if it repeats in this, does it like?
Well, if it repeats, that's like 2 and 2, but that's really a 4. So you just take one of them out.
You take one,
Because
two.
they will, if you were to multiply them, they would create a perfect square.
Uh-huh.
So you can then break that down. From a 4, it breaks down to a 2, the square root.
Okay.
It's like if you had a 3 and a 3, and you broke them down, and you combined, you have repeating numbers, so it's a perfect square of 9, but what you would remove is the square root of 9, which is a 3.
Okay.
You're just breaking down you're removing perfect squares from the number inside the radical.
Okay.
All right, so 15. We have 1,000 underneath. What do we know by our divisibility rules that can go into 1,000? 10. What else could go
100,
from our rules?
5,
5, 10.
50,
We're not going to count by fives.
5,
5 and 10. What else could go? Ends in double zeros.
500,
4 and 8. All right. So, what number do you want to start with for 1,000? Do you want to do, we could do 8, we could do 10, we can do, what do y'all want to do? What's the one that makes sense to you? 10, because it ends in 0. How many times does 10 go into 1,000?
100,
You know that because you can count your zeros over. 100. All right, is 10 a perfect square? Is 100?
Yes.
What are two numbers that multiply together that give you 100? 10. So 100 comes out as a 10. And we're left with a 10. So we break it down. It's not a prime number, but it breaks down into 5 times 2.
Those are problems.
Are either right? Good, Olivia. Neither of those are perfect squares. They're both prime numbers. So 10, while it's not prime, it doesn't contain anything perfect. So your final answer is 10, radical 10. And 10 squared is 100, so it goes back in. 100 times 10 will give you 1,000. 17 should be fairly straightforward as it matches number 5. All right, going to the back. Oops. All right, 19, radical 90. What do? What are two factors of 90? 10 and 9. Are either of those
Yes.
perfect? Which one? 9. 9 comes out as a 3. And we just broke down 10 into 5 times 2, and it doesn't break down into perfect squares. So 3 radical 10 is your answer. All right, 108. Can anybody tell me two factors of 108? 9 and 12. 108. Plus, you could do divisibility rules and find that 1 plus 8 is 9, so 9 does go into it. 9 times 12. I'm going to make my little playpen box out here. The 9 comes out as a 3. 12. What does it break down into? 4 times 3. Either perfect squares? 4. Breaks down as a 2. And then 3 is prime, so it has to stay. The outside number is what? Nope. Multiply those. 3 times 2, 6. Why? Because when we're breaking the 9 and the 4 down, we're breaking them down as to their factor. So we're putting them in this box, and they're factors. So when they get in there, they have to be multiplied. Okay? Does that make sense? Because it was, how did we get 3 from 9? It was 3 times 3. It's a factor. Yes, ma'am.
Why is it on like the on 19, like on the 10, you didn't keep factoring it, but on 20.1, you kept factoring it?
Well, that's because on problem 17, the last problem on the first page, we factored 10. And I referenced that and we just factored 10. It breaks down into 5 and 2, which are prime numbers, so 10 doesn't work. I just didn't do it again since we had just done it. But you need to do every one just as an in case. And that one happened to break down. Boyd,
Do you always put the first number like in the box?
do you always put the first number in the box?
Like the 3?
Whatever you break down from underneath the radical, I put over in the box. It's just a container to
Or
keep.
the 6.
The 6 always comes outside. It'll be 6 radical 3. The non-radical always is written before the box, before the radical sign. It won't be radical 3, 6. Is that what you're asking me? Kinda. Where to place the outside number?
Well, like, how do you know which number to put in the radical?
Okay, so 108. When we were breaking that down, we agreed 9 and 12. Everything right now is underneath the radical sign. And 9 is a perfect square, so it breaks down to a 3 right here. 12, we can break down further into 4 and 3. 4 is a perfect square. It comes out as our 2. Perfect square, for 9 and 4 will give us 3 and 2. What's left behind is this little 3. It's still under the radical. and it's a prime number, can't come out, so it stays under the radical.
Okay.
But these two numbers were removed because they were part of the perfect square regime. So we multiply them and they're the outside number. It's always written before the radical. All right, 96. 9 plus 6 is what number? Oh, I'm sorry. Hand.
I forgot my question.
Interrupt me if you think of it.
Yes, ma'am.
Okay? 23, 25, and 27, you work.
Oh, you think not?
Use your divisibility rules. 9 plus 6 is 15. What goes in? What would that be a rule for?
3.
3. Well, it's an even number. What else? What does that mean? 2. That means what else goes into it if 2 and 3 go into it?
6.
What about 96 divided by 4? Will 4 go into 96? Yeah. So, y'all have options. No. Right. So, I'll let y'all figure out 23, 25, and 27.
Wait, so if it divides into 2 prime numbers, which one goes in the...
Well, if it's 2 prime numbers, they don't leave at all. You can only leave the radical sign if you're a perfect square. Otherwise, you're stuck inside. Unless the prime numbers are same.
What the heck makes sense?
Wait, what are you supposed to do with 15?
That's what you get when you add 9 and 6. I was doing divisibility rules with you. You don't use 15. That's just what they equal, which means it's a divisibility rule for 3. Just trying to help you figure out how to start the breakdown of 96.
Like you don't put 3 in a box if you just get 3.
Like the 21, there's the 3 left behind. The only way 3 is in the box is if there was a 9 underneath,
Like if you knew 3 and 32, you wouldn't put 3 in the box.
because it's not a 9. Okay. What'd you get for 23?
4 and 6.
Well, how do you say it? That sounds like 24.
4 radical.
4 radical 6.
Dr. Boone,
Sir,
on 23, I did 3 and 32, and I got 3 to, I left a 3.
okay, hold on. You did 3, 32.
And I did the thing, the branches on 32, and I got 8 and 4.
8 and 4. Okay, the 4 breaks out as a
2, and then I put the 2 and the 4 in the box, and then I broke down the 8.
hold on, my pen is just all right, you there. And then we broke that 4 down to a 2. And then the 8 is what?
4 and 2.
4 and
And
2.
and then I took the 4 and put it to 2.
Uh-huh.
I was left with the 2.
You're left with this 3 also.
What, did you just multiply them?
Sure. They were multiplication problems to begin with, 3 times 32. And you kept breaking the 32 down. It's still, it's like you bring the 3 down each time. If you're not seeing that, bring the 3 down.
Wait, you just every time if there's like 2 left over, you multiply them?
Or 3 left over. If you have a 2 and, I mean, you could have several little things left in there. You just multiply whatever's left behind underneath, multiply whatever's out in that little box, and whatever's out in that box is outside, whatever's underneath is underneath the radical.
And
That's it.
what in the radical.
Last thing you do is check your radical number and be sure it's not a perfect square. And then 6 breaks down into 3 and 2. Won't go any further. All right, what did you get for 25? 256.
16.
Yes. What goes in the radical? Boyd, what goes in the radical?
Oh, I just got 16.
Right,
16.
16. Nothing goes in the radical.
That's
Perfect answer. All right,
But
how?
how do you, like, is there a rule?
No, he just worked it out, or either he knows his perfect squares. How'd you work it? Boyd,
Do what?
how did you work it?
I don't know. I just looked on the front and it was the answer.
What?
It's the same answer on the front.
Oh, yeah, it is. There is one of these on the front. But we broke it down. It's problem number 11.
Oh, it's 2 and 8.
Right. But, I mean, when we broke down 256, we did that one together. And you end up with 16, and there's no radical left behind. All right, 27. What did you get for 27? 8, radical 5. Are we good? Abels, did you get that?
I didn't get that far, but no, it's up there on paper.
Well, so what you would probably use is 32 times 10. And then break down from there to where you would have 8 and 4. And the 4 breaks down into 2 times 2. 4 comes out as a perfect square, so it would be a 2. The 8 is going to be 4 times 2. The 4 comes out as a 2. 10 is 5 times 2. All right, here is a 2, and here is another 2. So they're 4, so they come out as a 2. And then you're left with the 5. So 2 times 4, 2 times 2 is 4, times 2 is 8, radical 5.
I did 5 and 8, but I still got something.
Yeah, you would. All right, erasing. 192. What did you do? What could we do for 29?
3 times 64.
I hope you know. I hope you looked on the front page.
2 and 2.
6 and 32. 8 and 3.
8, radical 3. Thank you.
Oh, wait. I didn't know we were giving the answer.
Oh, well, we were, because we've already
I
worked
thought
it.
you were asking what the
Nah.
2 numbers that go into 190.
It just happens to be a repeat on the first page. Now, 31 is sort of like a repeat, but not quite. Ladies, shh, unless it's about math. Okay, math. You can quietly whisper. All right, is there a question there? You sure? If you're stuck on something, please ask. This has got to make sense for the next part to work. You okay? Yes, ma'am.
Can you phone us the factor things or like the multiplication rules?
The divisibility rules? I'm going to type one up and post it in Google Classroom, probably under divisibility rules. Okay? And that's a sheet for you. I'll have it typed up and posted today. And it is, y'all will have a quiz on that when? Monday. Monday. All right. 31. We have 2 radical 27. So really, technically, guys, if we draw our playpen, we already have a what in it?
2
A 2 is from the outside number.
and 9.
So then we break down radical 27. It's into what? Yep. What's perfect?
The 9.
Comes out as a
3.
3. What's my final answer?
6.
Radical
3.
3. Excellent.
Wait,
6. What's the 2 supposed to
yeah, we did.
This is like somebody,
The 2 was already in the book.
right, this is like somebody did their homework and didn't finish working it. They pulled a 2 out, but they left 27 as a non-workable number. Like it's not broken down any further. So we've come along and we're breaking it down because 9 and 3.
That's easy.
Right. So the 9 comes out as a 3 and you multiply it by the number already out there, 2.
You do it normally and then just add, multiply the extra thing and
If there's anything out there, you multiply it into what you've removed.
what about with the negative?
Oh, what is you figure out the rest of the page. I mean, in the odds category. These are easy. Super. And look at 33 and 37. They're the same radicals. So,
just multiply the outside number that you get.
yeah,
I did it. Those are easy.
these are easy.
Are we gonna have to do those with like the 3-digit ones too?
Sure.
6 and 2.
Wait, what now?
It says 33, 6 and a 2.
Well, 6 radical 2.
Yes. Yeah.
Yes,
Dr. Graham.
sir.
Negative.
33. I don't know what to put in the radical.
All right, so we draw our play box. And we already have a 2 because it was outside. And then we break down 18 into what 2 numbers? 9 and 2. Are either of those perfect squares?
9 and
What comes out as a what?
3.
2 is not breakdownable. So it's left behind on the radical. 2. 2 times 3 is 6.
But I thought you already had.
2.
Right. It is a number that's, if it's already outside, then it's like over in the box. So you take whatever you remove and
But I know
multiply.
That. It's just, the 2 in the when you're trying to figure it out, like what?
the outside number. Okay, let me say, hey guys, listen real quick. Outside numbers and inside radical numbers never cross over. We can't take that 2 that's outside and throw it back inside just as a plain old 2 and multiply it by the 2 that's in there and get 4. A radical does not carry the same value as the non-radical outside. So that bar, this radical bar thing right here, is like a concrete wall. It is not going to let the numbers cross over unless you have removed a perfect square from it.
So is the 2 like from a different equation that got to 18?
It is like somebody was doing their homework and said 2, all right, what's 2 perfect square for 2? It's 4, right? So 18 times 4 is going to be 72. So really, for 33, somebody was working the problem radical 72. And they knew, oh, it's divisible by 2 because it's an even. And they went 2 and they were left with 18. And you're just not through with the problem. So we came along and finished it.
Could there ever be a thing where it's 0 would be outside?
Well, we would never have, that means the radical inside is 0. The only time we would have a 0 out there is if we have the problem is 0. Yes, sir.
On number 35, do you work it just the same?
Yep, but what are you going to have over in the playground?
A negative.
-3.
But does it even matter if it's negative?
Yes, because a negative times a positive gives you,
Negative.
here you
So
go.
you want it to be positive?
No, you want the inside to be negative. Otherwise, it's an imaginary number, and we'll get to that next class. But the outside number can be negative.
So it's going to be like 9, negative 9 and 3.
Yes. -9, radical 3. Look at your cranium. It's working busy today. So then what is our answer for 37? Because we sort of worked it with 33.
9 and 2.
9 radical 2. Because instead of removing, we already had a 2. Instead, this time we already have a 3 out there. All right. And then 39.
I know it doesn't work.
What is it?
4 and 3.
4 radical 3.
So this is
Boyd,
What a roll.
you're like, you are not.
Okay.
he's singing louder.
Boyd.
Number 35, I did it in my head, but she.
No.
Oh, you didn't have Lillian's voice?
A box.
Lillian, I
Say it.
so
She
apologize.
should have been like bravely say it louder.
Well, I still know it.
Thanks for standing up for yourself. All right.
How would you
Shut
check
up.
this?
Okay. So